First example, find basis for solution solution space of the homogeneous linear system and also find dimension. So the given system, homogeneous system, is 3x1 plus x2 plus x3 plus x4 is equal to 0, and 5x1 minus x2 plus x3 minus x4 is equal to 0. So we want to determine the basis for solution space. So the first space we want to determine solution space here. So the step first, solution space, or it is also called null space, solution space. So first we want to express this system x is equal to, in the form of x is equal to b, where a is a coefficient matrix, x is a variable matrix, and b is a right hand side constant. So it is 3 1 3 1 1 1 1. Okay, sorry, not only 3 1 1, then 5 minus 1 1 minus 1. Variables are x1 x2 x3 x4, and the right hand side constants are 0 0. So now, since it is a homogeneous system, we want to reduce the matrix A to row echelon form. So 3 1 1 1, 5 minus 1 1 minus 1. So the first operation, we want the first entry should be 1, it is 3, so we can convert it into a 1 by multiplying 1 by 3 r1. So it is 1 1 by 3 1 by 3 1 by 3, then 5 minus 1 1 minus 1. Now by using the row operation, r2 is equal to r2 minus 5 times r1, we get it is 1 1 by 3 1 by 3 1 by 3, then 5 minus 5 0, then minus 1 minus 5 by 3, so it is equal to minus 8 by 3, then 1 minus 5 by 3, so it is minus 2 by 3, and minus 1 minus 5 by 3, so again it is equal to minus 8 by 3. So again we want to make this entry is equal to 1. So for that, multiply 3 by 8 minus 3 by 8 r2. So if you use this row operation, we get is 1 1 by 3 1 by 3 1 by 3, then 0 1 0 1, then to multiply minus 2 by 3 to minus 3 by 8, and this 3 will get cancelled here, minus minus become plus, so 2 by 8, which is equal to 1 by 4. So here 1 by 4, and here again minus 8 by 3 into minus 3 by 8 is equal to 1. Now this matrix is in row echelon form. So again, if we express this matrix into a system form, we get, now here leading variable, first of all we want to identify the leading variables. Now this one, leading one corresponding to x1, this leading one corresponding to x2, and x3 x4 are free variables. So leading variables are x1 x2, and free variables are x3 x4. So again, if we express this into a system form, we get x1 plus x2 by 3, x2 by 3 plus x3 by 3 plus x4 by 3 is equal to 0, and x2 plus 1 by 4, that is x3 by 4 plus x5 equal to 0, x4 is equal to 0, and here x3 x4 are free variable, so put x3 is equal to t and x4 is equal to r. They are free variable where t and r are real numbers, okay, and therefore by using this free variable, we are going to express leading variable in terms of free variables. So what is x2 here? x2 is equal to minus x3 by 4, so minus t by 4 minus x4, so it is minus r. x2 is minus t by 4 minus r. Then last, it is equal to last is what? x1. So what is x1 here? x1 plus x2 by 3, so x1 plus x2 by 3, so it is 1 by 3 minus t by 4 minus r plus 1 by 3 x3, which is t, and 1 by 3 r. So if you simplify this, is equal to what? Is equal to 0. So if you simplify this, x1 minus t by 12, then minus r by 3 plus t by 3 plus r by 3, so this r by 3 get cancelled here, so equal to 0. So x1 is equal to t by 12 plus t by 12 minus, not plus, minus t by 3. So if you take here LCM, then x1 is equal to t minus 4t divided by 12, so it is minus 3t divided by 12. x1 is equal to minus 3t divided by 12, so x1 is equal to minus t divided by 4. So this is the value of x1. Now you can use a maxima also to find this solution, but first of all we are going to write here solution space. So here solution space, x is equal to x1, x2, x3, x4, which is equal to, what is x1 here? Minus t by 4. x2 is equal to, x2 is minus t by 4 minus r, and what is x3? x3 is equal to t, x4 is equal to r. So we can write this as minus t by 4 minus t by 4 t 0 plus 0 minus r 0 r. So here solution space is, so here solution space is equal to minus 1 by 4 minus 1 by 4 1 0 into t plus 0 minus 1 0 1 r, where t and r are real numbers. Okay, so this is a solution space, that is this space is formed due to a span of these two vectors. This is the first vector and this is the second vector. So what is the basis for solution space? So basis for solution space is equal to minus 1 by 4 minus 1 by 4 1 0 and 0 minus 1 0 1. So it contains two bases. So what is the dimension of null space here? The dimension of solution space, it is also called nullity space, which is equal to nullity, okay, is equal to 2. So number of bases is equal to 2, so the dimension is equal to 2. Now you can use a maxima also to obtain a solution for this system, 3x1 plus x2 plus x3 plus x4. For that, if you use the command, say len sol 3x1, so 3 star x1 plus x2 plus x3 plus x4 plus x4, and the second equal to 0, and the second equation is 5 What is second equation here? 5x1 minus x2 plus x3 minus x4. So 5 star x1 minus x2 plus x3 minus x4 is equal to 0, and the variables are here x1, x2, x3 and x4. Sorry, x4. Now, okay, and if you press here, you can see here x1 is equal to what? They use the p variable as r2 by 4, and we obtain x1 is what? X1 is minus t by 4. You can check here. What is x1? X1 is equal to minus t by 4. Then what is x2? R minus time r2 plus 4 times r1. So it is the same as, if you take the minus sign common here, if you write this as, you can write this as a minus sign common, t plus 4r divided by 4. So this is x2. What is x3? R2, and x4 is r1. So it is, we instead of t and r, they use r1 r2. So next example number 2. Find the rank and nullity. Find the rank and nullity of the matrix A. Here A is equal to 1 minus 2, 2, 3 minus 1, and minus 3 6, minus 1 1, minus 7, and last is 2 minus 4, 5 8 minus 4. So the basis of row space or column space or range space is called the rank of the matrix A. So first of all, we are going to reduce this matrix A to row echelon form. So the R2 is equal to R2 plus 3 times R1, and R3 is equal to R3 minus 2 times R1. If you use this row operation, we get 1 minus 2, 2, 3 minus 1. Okay, minus 3 plus 3 0. Then 6. Next 6 minus 6, it is equal to 0. 6 minus 6. Sorry. 6 minus 6 0. Then minus 1 plus 6 5. Then 1 plus 9 10, and minus 7 minus 3, it is minus 10. Similarly 2 minus 2 0, minus 4 plus 4 0, 5 minus 4 1, 8 minus 6 2, and minus 4 plus 2, it is minus 2. Next, we want to convert this entry is equal to 1. So for that, we are going to use the row operation, 1 by 5 into R2. So it is equal to 1 minus 2, 2, 3 minus 1 into 0 0 1 2 minus 2, 0 0 1 2 minus 2. Now by using the row operation R3 minus R2, we get here 1 minus 2 2, 3 minus 1, 0 0 1 2 minus 2, 0 0 0 0 0. Okay, so now this matrix is in row echelon form. Now the basis for row space, these are the two bases for row space. Or you can see here number of non-zero rows is equal to 2. So you can see here these are the leading ones. So again the column space contain only two bases, Okay, and row space is also contain two bases, or in other words, you can write here basis for row space. Row space is equal to 1 minus 2, 2, 3 minus 1, and 0, 0, 1, 2 minus 2. So here two bases, therefore rank of A is equal to 2. Now next we want to determine nullity. Nullity is the dimension of solution space. Or what is the nullity here? Next step number 2, say here. So nullity is nothing but the dimension of null space, okay, or in other words solution space. So consider a homogeneous system. System x is equal to 0. So x is equal to 0 implies what is A here? 1 minus 2, 1 minus 2, 2, 3, 1 minus 2, minus 2, 2, 3 minus 1, minus 1, then minus 3, 6, 6, minus 1, 1, minus 7, 2 minus 4, then 5, 8 minus 4. So into x, so what is here x? It is x1, x2, x3, x4 and x5 is equal to 0, 0, 0. So now again we want to reduce this matrix to row echelon form, but already we have reduced this matrix into row echelon form in previous step. So the row echelon form is what? 1 minus 2, 2, 3. So what is the row echelon form here? I am writing here A is equal to 1 minus 2, 2, 3 minus 1, 0, 0, 1, 1 minus 2, 0, 0, 0, 0, 0. So this is the row echelon form of the matrix A. Now here 0, what is 0, no, sorry, 1, 2 minus 2, here not 1, it is 1, 2 minus 2. Now here you can see the leading variables are x1 and x3. Leading variables are x1 and x3, and free variables are x2, x4, x5. So again, if we express this into a system form, we get x1 minus 2x2 plus 2x3 plus 3x4 minus x5 is equal to 0, and x3 plus 2x4 minus 2x5 is equal to 0. Then here since it is a free variable, x4, x2 is equal to say t, x4 is equal to r, and x5 is equal to s, where r, t and s belongs to, they are all real number, and therefore this is the value of x2, the value of x4, and this is the value of x5. So what is x3 here? x3 is equal to minus 2x4 plus 2x5. So it is equal to minus 2r plus twice s. So this is the value of x3. x3 is equal to minus 2r plus twice s. Now next x1. So what is x1 minus 2x2? So the x1 minus 2t. Then next equation 2x3. So plus 2 times minus 2r plus twice s plus 2x3 plus thrice x4. So what is x4? Thrice r plus thrice x4 minus x5. So minus x5 is what? S. Minus x5 is s is equal to 0. So x1 minus 2t plus minus 4r plus 4s plus thrice r minus s is equal to 0, and therefore x1 is equal to minus 2t, so it is 2t, Okay, minus 4r plus 3r minus r, so it is plus r, and 4s minus s, it is plus thrice s, so it is equal to minus thrice s. So this is the solution for x1, x2, x3 and x4. So if you write this into in terms of x, if you write here x is equal to x1, x2, x3, x4, x5, then this is equal to x1 is equal to 2t plus r minus thrice s, x2 is equal to minus 2r plus twice s, minus 2r plus twice s, x3 is equal to x2 is equal to t, I think. Sorry, this is what so x2 is equal to t, and x3 is what, minus 2r plus twice s, minus 2r plus 2s, x4 is equal to r, and x5 is equal to s, r and s. So this can be written as, this is equal to 2t t 0 0 0 plus the terms containing r, so it is r0 minus 2r r 0, and terms containing x are minus thrice s, then 0 twice s, 0 s. So here solution space or null space is equal to 2 1 0 0 0 t plus 1 minus 2 1 0 minus 2 1 0 into r plus minus 3 0 2 0 1 yes, where r, s and t, they are all real numbers. This is solution space. This solution space is spanned by three vectors 2 1 0 0 0, 1 0 minus 2 1 0, and minus 3 0 2 0 1. Therefore basis for null space is equal to 2 1 0 0 0, 1 0 minus 2 1. Okay, I'm writing again. Minus 2 1 0, and minus 3 0 2 0 1. Okay, and therefore here nullity is equal to 3. So what is the dimension? Number of bases is equal to 3, so nullity is equal to 3. Now you can use a maxima to find the rank, and to solve this system you can use a maxima here. So if we enter this into a matrix form, say A is equal to matrix, okay, the first row is 1 minus 2 2 3 minus 1, the second row is minus 3 6 minus 1 1 minus 7, and the third row is 2 minus 4 5 8 minus 4. So you get the matrix A, and if you write here rank of A, then rank of A is equal to what, 2. Now to get a solutions for this homogeneous system, if you write solve, say the first matrix, the first equation is x1 minus 2 x2, okay, x1 minus 2 x2 plus 2 x3 2 star x3 plus 2 star x4 1 minus 2 2 3. So this 3 star x4 plus minus x5 equal to 0, Then the second equation is minus 3 star x1 plus 6 star x2 plus minus x3 plus x4, okay, x4, then minus 7 times x5 equal to 0, and the last equation is 2 star x1 minus 4 star x2 plus 5 star x3 plus 8 star x4 minus 4 star x5 is equal to 0, and here variables are x1, x2, x3, x4, x5, and you can check here. So what is x1? It is 2 r5 plus r4 minus 3, so 2r5, so 2r5 plus r minus 3 thrice, yes. So they are use r1, r2, r3, r4, r5, okay. x2 is r5, x3 is 2r3 minus 2r4, so you can check here, minus 2r plus twice s. So this way you can get a solution for homogeneous system. Now the next example, find the basis for column space A, find a basis for column space so the A is equal to given, A is equal to 1 2 0 0 2 5, then minus 2 minus 5 1 minus 1 minus 8, then 0 minus 3 3 4 1, and 3 6 0 0 minus 7 2. So the first we want to use here R2. First we want to reduce this matrix to row echelon form, so R2 minus plus 2 times R3 R1, then R4 minus 3 times R1, so it is 1 2 0 2 5, then next minus 2 plus 2 0, minus 5 plus 4 minus 1 1, then minus 1 plus 4 3, and minus 1 plus 4 3, and next minus 8 plus 10, it is equal to minus 8 plus 10 2, next it is 0 minus 3 3 4 1, and last 3 minus 3 0, 6 minus 6 0, it is 0, then minus 7 minus 6 minus 7 minus 7 minus 6, it is equal to minus 7 plus 6 is equal to 1, and next this 2 minus 15, it is equal to 2 minus 15, it is equal to minus 13, this is equal to here, this is equal to minus 13, and here minus 7 minus 6, it is equal to minus 13, plus 13, minus 7 minus 6 minus 13, and 2 plus 2 minus 15 minus 13. Now next for this entry we want to make 1, so for that uh, we want to multiply minus into R2, so we get 1 2 0 2 5, then 0 1 minus 1 minus 3 minus 2, 0 minus 3 3 4 1, and 0 0 0 minus 13 minus 13. So our next step, we want to make this into 0. So for that we are going to use the row operation R3 plus 3 times R2. So if you use this operation, we get 1 2 0 2 5, then 0 1 minus 1 minus 3 minus 2, 0 0 0 4 minus 9, it is 5, and 1 minus 6, it is minus 5. So 4 minus 9, 4 minus 9 is minus 5, sorry, and then 0 0 0 minus 13 minus 13. Next we want to make this minus 5 into 1, so for that minus 1 by 5 into R3. So if you use this row operation, we get 1 2 0 2 5, then 0 1 minus 1 minus 3 minus 2, 0 0 0 1 1, 0 0 0 minus 13 minus 13. So now next, if we use here R4 plus 13 times R3, then we get, it is equal to 1 2 0 2 5, then 0 1 minus 1 minus 3 minus 2, then 0 0 0 1 1, and 0 0 0 0 0. Now this matrix is in row echelon form. So here leading ones are a1 2 and 3 leading ones, and their original column vectors form a basis for column space. So the first, second and fourth column form a basis for column space. So here basis for column space are, so I am writing here, this is the first vector form of first, then next is what, 2 and fourth, the second, and these are the three vector form a basis for column space. So what is the column space? I am writing here, column space, basis for space, basis for column space is equal to 1 minus 203, 1 minus 203, then next is 2 minus 5 minus 3 minus 3 6, next is 2 minus 1 1 4 minus 7. So these are the basis for column space. And here, and therefore what is the row rank here? Row rank is equal to 3 or rank is equal to 3. Our next example, the last example, example number 3. The last example is find a subset of the vectors that form a basis for space spanned by the vectors v1 bar, v2 bar, v3 bar and v4 bar, and then express each vector not in the basis as a linear combination of basis vector. So here the space is spanned by these 4 vectors, and we want to determine what are the basis for the space which is spanned by these 4 vectors. That is, here the subspace is formed, due to alpha 1 v1 bar plus alpha 2 v2 bar plus alpha 3 v3 bar plus alpha 4 v4 bar. So now where alpha 1, alpha 2, alpha 3, alpha 4, they are all scalars. So here to find a basis for this subspace spanned by these 4 vectors, that we want to remove here some dependent vectors. So to remove these dependent vectors, we want to reduce the matrix into row echelon form. So here matrix A is equal to So to consider here alpha 1 times v1 bar, then we get alpha 1 times the first is what, alpha 1 times 1001 1011 plus alpha 2 times minus 3371 plus alpha 3 times, so it is alpha 3 times minus 1393 and plus alpha 4 times minus 53 3 5 minus 1. Okay, so what is the space spanned by these four vectors? So if we can write this as, so in a matrix form as A is equal to, so we consider here the row vectors of this matrix A, which contain row vectors of this vector. So it is one rows contain this vector 1 0 1 1, then minus 3 3 7 1, minus 1 3 9 3, and minus 5 3 5 minus 1. So we want to reduce this matrix to row echelon form. So for that we are going to use R3 R2 plus 3 times R1, R3 plus R1, and R4 plus 5 times R1. So if you use this row operation, we get 1 0 1 1, then minus 3 plus 3 0, it is 3, 7 plus 3 10, and 1 plus 3 4, then minus 1 plus 1 0 3, 9 plus 1 10, and 3 plus 1 4, last minus 5 plus 5 0, then 3, 5 plus 5 10, and minus 1 plus 5, it is equal to 4. So you can see here these three vectors are same. So if we use here R3 minus R2 and R4 minus R2, we get all it is equal to, we get 1 0 1 1 1 1 into 0 3 10 4 0 0 0 0 0 0 0 0. Now this is equal to, this is same as alpha 1, this if we divide 1 by 3 into R2, then we get 1 0 1 1 0 1 10 by 3 and 4 by 3 0 0 0 0 0 0 0 0. Now this matrix is in row echelon form, and therefore the basis for the subspace spanned by these vectors is, or basis for row space is for subspace spanned by these four vectors are equal to 1 0 1 1 and 0 1 10 by 3 4 by 3. Next we want to write this into again those vectors which are not in basis. So you can see here, so this the third vectors and fourth vector are not in basis. We want to express this into a basis. So for that we can write